DSPy employs modular abstraction to encapsulate language model interactions, treating prompting as a composable, parameterized computation. The framework's core mechanism revolves around defining reusable modules that declare input-output signatures and delegate execution to configured language models. We will now examine how this modular architecture is initialized, beginning with language model configuration and progressing to the declaration of a ChainOfThought module. The upcoming code demonstrates the foundational patterns for instantiating DSPy components and establishing their operational context.
Import DSPy. Hash define our language model. LM equals DSPy. LM model equals OpenAI/GPT-4o mini. Max tokens equals 250. DSPy. Settings. Configure elm equals LM. Hash define a ChainOfThought module. Class COT DSPy module. Def in itself. Super.init. Self-prog equals DSPy. ChainOfThought question answer. Def forward self question. Return self. Prog question equals question. DSPy model equals COT.
This code demonstrates the foundational setup for using DSPy with a ChainOfThought module. The pattern establishes a language model configuration and creates a modular component for question-answering tasks. The DSPy LM class initializes the language model with specific parameters, while DSPy settings configure sets this as the default model globally. The COT class inherits from DSPy module, encapsulating the ChainOfThought prompting technique through DSPy ChainOfThought. This modular approach allows for composable and reusable components in LM pipelines. The ChainOfThought module is particularly useful for complex reasoning tasks, as it encourages the model to generate intermediate reasoning steps before producing the final answer. This technique often improves performance on tasks requiring multi-step reasoning. The code shows how to declare a signature, question-answer, that defines the input-output behavior of the module, making it clear and self-documenting. The forward method demonstrates how to invoke the module with a question input. This setup provides a clean separation between model configuration and task-specific logic. The global configuration via DSPy settings configure ensures consistency across modules, while the class-based approach allows for easy extension and composition. The ChainOfThought module abstracts away the prompting details, letting developers focus on the task logic rather than prompt engineering. This pattern is especially valuable in production scenarios, where you need to maintain consistent LM behavior across different parts of an application. Let's break it down.
Import DSPy.
Imports the DSPy framework, which provides tools for building and optimizing programs that use language models.
Hash define our language model. LM equals DSPy. LM model equals OpenAI/GPT-4o mini. Max tokens equals 250.
Creates a language model instance using DSPy's LM class, configured with the OpenAI GPT-4o mini model and a maximum token limit of 250. The variable LM now holds this configured language model ready for use in subsequent operations.
DSPy settings configure elm equals LM.
Configures DSPy's global settings to use the specified language model, LM, as the default for all subsequent operations. This sets the language model that will be used by DSPy modules unless overridden in a specific context. The LM parameter is passed to the configuration method to establish this default behavior.
Class COT DSPy module
defines a new DSPy module class named COT that inherits from DSPy module, establishing it as a custom building block for language model programs. This creates a foundation for implementing chain-of-thought reasoning patterns while maintaining compatibility with DSPy's module system for composition and optimization.
Def in itself
defines the constructor method for a class, which initializes a new instance of the class when called. This is the standard Python initialization method that runs automatically when an object is created from the class.
Super.init
calls the parent class's init method to initialize inherited attributes and behavior. This ensures the current class properly inherits and sets up any base functionality defined in its superclass.
Self-prog equals DSPy. Chain-of-thought question answer
creates a chain-of-thought module instance named prog that maps a question input to an answer output. This module will use the chain-of-thought prompting technique when processing inputs, generating intermediate reasoning steps before producing the final answer.
Def_self question
defines a method named forward that takes self and question as parameters. This is a standard Python instance method declaration where self refers to the instance of the class, and question is an input parameter that the method will process. The method is likely part of a DSPy module or signature class, given the context, but the line itself only shows the method definition without any implementation details.
Return self. Prog question equals question
calls the prog method of the current object with a keyword argument, question, set to the value of the question variable, then returns the result. This is a standard method invocation where the method processes the input question and returns its output.
DSPy model equals COT
creates an instance of the chain-of-thought module from DSPy and assigns it to the variable DSPy model. This initializes a module that implements the chain-of-thought prompting technique, which is designed to break down complex reasoning tasks into intermediate steps. This implementation showcases DSPy's modular architecture for language model interactions, where prompting is treated as composable computation. The pattern begins with language model configuration using DSPy, LM, which sets up the OpenAI GPT-4o mini model with a 250 token limit. This configuration is then established as the global default through DSPy, settings, configure, ensuring consistency across all modules. The chain-of-thought module demonstrates how DSPy encapsulates prompting techniques into reusable components. By inheriting from DSPy module and declaring a chain-of-thought instance with a clear input-output signature, question-answer, the code abstracts away the prompting details while maintaining flexibility. The forward method shows how this module processes inputs, generating intermediate reasoning steps before producing the final answer, a technique particularly valuable for complex reasoning tasks. The key insight here is the separation of concerns. Model configuration is handled globally, while task-specific logic is encapsulated in modular components. This design allows for easy extension and composition, making it straightforward to maintain consistent language model behavior across different parts of an application. The chain-of-thought pattern specifically highlights how DSPy's modular approach can improve performance on tasks requiring multi-step reasoning by encouraging the model to generate intermediate steps before final answers.
The chain of thought weaves answers from silence, while the prompt listens to its own echoes.